Okay, so you'll recall we were designing the software to do the architect scenario. Well, you can't do the architect scenario on that thing, so it became simple forms-based information management. I just made up this phrase yesterday. I don't know what we called it. And I have this great picture that we made of all the different kinds of forms. It's like a brainstorming thing of like, what do you mean by a form? And we made a bunch of these little apps, but I couldn't find both of us just moved, so we're having a hard time finding our memorabilia. But maybe you have, maybe I have it in there somewhere.
Here, your prop pile's building up here.
But I have an example here. I mean, so basically, no, these are actual apps.
Oh, you wanted the...
No, this is like, what do you mean form? Like, what do you mean simple form-based app?
Caps used to always, in a kind of a sneering way, call this the tip calculator.
Yes, the tip calculator. That's a classic form.
We got to have something that can do something more than the tip calculator, because that was his kind of dig on the sharp wizard. And
yeah, this was back when they were releasing, PDAs, because we had announced the concept at some point, and people were releasing these things like that would do almost nothing, but they were cheap.
We're actually shipping.
Yes.
And so we had a bunch of ideas, and one of the canonical early samples was the pizza order form.
That's right. See, that's on this page I can't find. The pizza order form with the little pizza and the ingredients.
And you could do like half pepperoni, half black olive, and then click fax, and it would fax to your local pizza place, and it would pull the pizza place's address from the soup.
This is back when fax was high tech.
Yeah.
So I think we implemented all these for the actual message pad just to, I know we had a tip calculator. I know we had a tip calculator because somebody thought that was funny.
Yeah.
So this is the architecture at this point, and you can see the whole thing is written in C++, except for a very thin layer on top, which is the apps, and the apps are very, very simple. But we had changed things, like instead of this Skia thing, which was kind of big and complicated, we were using QuickDraw. Now this is actually difficult to do because QuickDraw was written in 68,000 assembly, and of course you can't run that on an ARM, completely different processor. But it turned out that somebody had converted the source into C. It's very mechanical C. So like in assembly, you'd say, add 1 to register A0. In C, it would say A0 equals A0 plus 1. So it wasn't really written in C. It was just converted into C so that you could recompile it. And of course, it wouldn't work as well as the original assembly, but it would still work. And they did this to port it to, remember there was this very old product that was an accelerator board for QuickDraw that ran I think it was the 29,000 processor. So they had the same problem. They had to get it into C. So we stole that. There's still an object store, but now there's this new layer. So the idea with forms is that you would have a database, and it would have these things called frames. And so this is your address book, pretend. And you basically just have a soup of information, no actual structure. And so each example here, you see that there's a full name, an address, and some phone numbers. And the idea of a simple form-based application is it's something like the address book or the calendar or a pizza ordering form where you don't have a lot of complicated interaction. It's kind of more like a FileMaker application. You design a form and then you link it up to the data. So if you think about the address book, you basically get a form that says, here's how to display a person, and here's the next and previous buttons. And you put in the form the connection to the database. So you say this field should have the full name in it, and this should have the address in it, and this should have the phones in it. So as you push next and previous, it just links to a different record and displays the stuff. So you can go back and forth. It just automatically links up. So as an application vendor, all you have to do is define the form, the appearance of the form, and tell it what to link up to in the data. Now this doesn't actually get you very far, it turns out. This is like a really, really simple idea, but as soon as you really start to do it, you realize that what really happens is more like this. You have data that has not a full name, but a first name and a last name. And so when you want to make the form like that, you can't just link it to one of the fields because there is no field that says Walter Smith. So you have to have an expression. You have to say first name plus last name. So I implemented this. I actually did frames mostly on my PowerBook 100 sitting on my porch swing at home, which is, I can't imagine doing anything on a PowerBook 100 nowadays. But so I brought in the frames because CAPS had sort of a wacky prototype frame-ish kind of thing. So I kind of regularized it and gave it actual architecture. and gave it back to him. And then he said, "This is cool. I'm going to redo the view system to talk to this frames thing." So he did these linkages, through these tags. That was working. And then he said, "No, what I need here is expressions. This tags thing is not good enough." I said, "Oh, that's no problem. I give you expressions." So I wrote a little compiler, a little parser to do simple expressions, kind of like Excel. You just put a little formula. Well, of course, that wasn't good enough because then you needed if-then statements. Because you want to say, if the state is taxable, then multiply by the tax rate and so on. So I gave it if-then. Then you need to define little functions because you're like, well, I want to encapsulate the taxes, in the tax rate function, so I can just apply that in multiple places. Well, as soon as it got functions, of course, then it was a language. So it kind of started to grow from there, and people started to say, why can't I just write my form event handlers in this language? And I said, well, I guess you could just put a function in a frame slot, and then you'd be able to call the handler. That would work. Let's try that. So it kind of grew from there. And before I knew what I was doing, I was a language implementer, which you'll recall was what we explicitly decided we were not going to do. So then, as this was going on, the junior team was growing because it was becoming obvious it was going to be a real product, even though we weren't quite sure what it was, but we knew a lot more about it than senior. And so in my diagram here, you can see we're diverting resources over to junior. And at some point, it became clear that we really needed everybody on junior to be able to get anywhere close to our ship date, which Scully had insisted on. And we pre-announced at CES what the date was, right?
A little bit.
So May 92 is the CES, is that right?
Yes.
And then May 93? August 93.
Macworld?
No, May 29th was the, oh no, that was CES. Yeah, it was August Macworld, that's right.
It was the launch. But
So we announced a year before we thought.
And part of the reason that happened, just to tell you the inside story, is that we were constantly fighting for our collective lives as this group. That there were a number of probably quite reasonable reasons why maybe it didn't make sense for Apple to do this at the time. And there was a group within the worldwide marketing group that owned the PowerBook product line that had basically had gotten the Mac OS running on a shrunken down PowerBook as a prototype. And so there was this pressure from Scully saying, you guys got to make this thing real, otherwise, our handheld strategy is going to get driven by the Mac group. So we said,
Yeah.
okay, let's take a classic page out of the marketing textbook, let's announce the platform. So we, without knowing that we didn't have product, we had no choice but to announce the thing.
To preempt all the competing platforms that also didn't exist.
To shut down all the competing
And so the thing we showed at CES was actually basically Caps's prototype compiled for the ARM card. So we could honestly say this is running on prototype hardware, but we didn't mention that actually that had nothing to do with the actual software we planned to ship.
F2FX had a hole cut in it because the card stuck out.
Yeah, the card. Well, you can see that this card is huge. So yeah, we showed it was running inside a Mac because we didn't have the bun warmers at that point. So this eventually developed to the point where we said, okay, look, we got to have everybody on this junior thing because we're doomed otherwise. The amazing thing to me is I look back on the schedule, and it starts in 1987 when Special Projects started, and it seemed like forever. But this is like 92 at this point. So it's only been 5 years. In fact, I've only been there 4 years. Now, at my age now, I say 4 years. It takes me longer than that to have breakfast. But back then, it seemed like forever.
Microsoft.
Oh yeah, Microsoft is maybe used to taking 10 years to ship anything. So this is what happened then. We basically switched everybody to junior, and a small team of people who were still convinced that if they could just get it to work, Dylan would be the obvious answer. So I think like maybe 5 people who were kind of the most advanced Dylan users, because we'd recruited some more people from ATG and so on who were really smart, and they kind of understood what to do with it. They went off, and they made one last attempt to get that software to work. And they actually did some incredibly cool things, but not cool enough. So the Coral
software people?
Oh, the Coral people, well, they were in Cambridge the whole time. They never even came to Cupertino. In fact, they still continue to work on Dylan. So even after this point, where everybody moved to junior, they still worked on Dylan. And that's why we have Dylan today. It basically became an ATG-only project.
They were part of